Hello friends, I welcome you in lecture number 8 on exponential distribution. In this lecture we will discuss one more problem on exponential distribution. So let's start with this example. The time between calls to a plumbing supply business is exponentially distributed with a mean time between calls of 15 minutes. So it is given that time between calls is exponential random variable with mean equal to 15 minutes. Now using this information we have to find these different probabilities. First probability is probability that there are no calls within a 30-minute interval. In part B, we are asked to find the probability of at least one call arrival within a 10-minute interval. In part C, we have to find the probability that first call arrives within 5 minutes and 10 minutes after opening. And in part D, determine the length of an interval of time such that the probability of at least one call in the interval is 0.90. So we will do one by one all these subparts. So first we write down what is our random variable. So it is already given that the time between calls to a plumbing supply business is exponentially distributed. So this time between calls is an exponential random variable with mean mu equal to 15 minutes. So here we have written that let capital X equal to time between calls. So it is given that X follows an exponential distribution with mean mu equal to 15 minutes. And we know that the parameter lambda of exponential distribution is related to mean by this relation lambda equal to 1 over mean, and here mean is 15, so we have lambda equal to 1 by 15 calls per minute. So this is the decay parameter for this exponential random variable. So because we are now having value of lambda, we can write the cumulative distribution function of exponential random variable. This is the formula for CDF. Fx equal to 1 minus e raised to minus lambda x for non-negative values of x and 0 for negative values of x, and here we put lambda equal to 1 by 15 and we get this fx as 1 minus e raised to minus x by 15 if x is non-negative and 0 if x is negative. And we know that this is nothing but probability that time between calls. So time between calls is nothing but capital X is less than or equal to small x. Now in first part we are asked to find the probability that there are no calls within a 30-minute interval. So we can find out this probability. Suppose this is interval of 30 minutes and this denote the time in this interval. So we have to find the probability that there are no calls in this 30-minute time interval. In part A, we are asked to find the probability that there are no calls within a 30-minute time interval. So in this time interval there are no calls, and our x is nothing but time between calls. So if value of x is more than 30 minutes, then there will be no calls in this 30-minute interval. So the event that there are no calls in this 30-minute interval is equivalent to the event that time between calls is more than 30 minutes. So we have written here probability that there are no calls in a 30-minute interval is nothing but probability that waiting time between calls is more than 30 minutes, and time between calls is nothing but our random variable capital X. So this we can represent by capital X is strictly greater than 30. Now we know that these two events are complementary events. x greater than 30 and x is less than or equal to 30 are complementary events, so sum of their probabilities must be 1. So probability of this event equal to 1 minus probability of this event, and this is probability that capital X is less than or equal to 30 is nothing but value of this CDF at x equal to 30. So here we put x equal to 30. So this is equal to 1 minus value of CDF at 30. It is 1 minus e raised to minus 30 by 15, and after simplifying we obtain this probability as e raised to minus 2, which is approximately equal to 0.1353 up to 4 decimal places. So this is the probability that there are no calls in 30-minute time. Now we move towards part B. In part B, we are asked to find the probability that at least one call arrives within a 10-minute interval. So let's try to do part B. So in part B, we have to find the probability of the event that at least one call arrival in a 10-minute interval. Now if we think about complementary event of this event, complementary event of this event, our event is at least one call in 10-minute interval. So what will be the complementary event of this event? So that event is nothing but no calls in 10-minute time interval. These two events are complementary events. Event that at least one call in 10-minute interval and no calls in 10-minute interval. These two events are complementary events. So probability of this event at least one call in 10 minutes will be equal to 1 minus probability of this event no calls in 10-minute interval. So that I have written here, probability of at least one call in a 10-minute interval is equal to 1 minus probability of no calls in a 10-minute interval. Now if there are no calls in a 10-minute interval, then as we know this is the time between calls. So there are no calls in this time interval 0 to 10. So this is equivalent to saying that time between calls must be more than 10. Okay. If time between calls is greater than 10 minutes, then there will be no calls in 10-minute interval. So again I can write this event as time between calls is more than 10 minutes. So this I have written as probability that time between calls is more than 10 minutes, and this we can represent by capital X is strictly greater than 10, because capital X represent the time between calls. So that I have written here. Now again we know that x greater than 10 and x is less than or equal to 10 are complementary events. So probability of this event and this probability of this event must sum to 1. So this probability can be written as probability that x is less than or equal to 10. And now this is nothing but value of CDF at x equal to 10. So this is equal to value of CDF at x equal to 10. CDF is 1 minus e raised to minus x by 15 if x is non-negative. So here we put x equal to 10 and we obtain our required probability. After simplifying, we obtain that this is the probability of at least one call in 10-minute time interval. Probability of at least one call in 10-minute time interval is 0.4866. Okay, so again I repeat here I am asked to find the probability of at least one call in 10-minute interval. So this I can write as 1 minus probability of no calls in 10-minute interval, because these two events are complementary. Now no calls in 10-minute interval is equivalent to the event that time between calls is more than 10 minutes, and using this value of CDF I am able to find this probability. Now what is part C? In part C we have to find the probability that the first call arrives within 5 minutes and 10 minutes. So time between calls is in between 5 and 10. So arrival of call, time between call arrivals is 5 to 10. Probability that the first call arrives within 5 minutes and 10 minutes after opening. So we have to find out this probability, that capital X lies between 5 and 10. So in part C, probability of first call arrival within 5 and 10 minutes is equal to probability that X lies between 5 and 10, and this we can rewrite as probability that X is less than 10 minus probability that X is less than 5. This is nothing but value of CDF at 10, this is value of CDF at 5, and our CDF in this example is 1 minus e raised to minus x by 15. So to find out this we put x equal to 10, and for this we put x equal to 5. So this is 1 minus e raised to minus 10 by 15 minus 1 minus e raised to minus 5 by 15, and here we can cancel out this 5 here. So we have e raised to minus 2 by 3, here we have e raised to minus 1 by 3, 1 will cancel out, and after simplifying this we obtain this probability up to 4 decimal places. Time between calls is in between 5 and 10 minutes is 0.2031. And the last part is determine the length of an interval of time such that the probability of at least one call in that interval is 0.90. So here we have to find out the time interval, length of time interval such that probability of at least one call in that time interval. Here probability is given, probability is 0.90, but length of interval is not given. We are asked to find out the length of an interval of time or length of time interval such that probability of at least one call in that time interval is 0.90. So we assume that suppose length of time interval is x. So we are asked to find out value of this small x, which is length of time interval, such that probability of at least one call in x time interval is 0.90. So we assume that length of time interval is x, and we try to find out value of x. So here we have written, suppose that the probability of at least one call in x minute time interval is 0.90, and we want to determine the value of x. So we can start in this way. It is given that probability of at least one call in some time interval, which we assume that time interval is of x minute. So probability of at least one call in x minute interval is given to be 0.90. Now this event, at least one call in x minute interval and no calls in x minute interval, these two events are complementary events. So I can write down this probability as 1 minus probability of no calls in x minute interval equal to 0.90. Here I am using the fact that at least one call and no calls, these two events are complementary events. So probability of at least one call in x minute interval is equal to 1 minus probability of no calls in x minute interval. Now again if there are no calls in x minute interval, then time between calls, which is capital X, must be greater than small x. So this event, no calls in x minute interval, is equivalent to the event that time between calls is more than x minutes. If time between calls is more than x minutes, then there will be no calls in this time interval x. So these two events are same. No calls in x minute interval equal to time between calls is more than x minute. So I replace this probability by probability that time between calls is more than x minute. And this probability I can represent by this capital X is greater than small x. Now these two events are complementary events. Capital X is greater than x and capital X is less than or equal to x are complementary events. Therefore we can write this probability as probability that capital X is less than or equal to x is 0.90. Okay, because these two are complementary events, so sum of their probabilities must be 1. Therefore 1 minus probability that capital X is greater than small x equal to probability that capital X is less than or equal to x, and this is nothing but value of CDF at point x, and value of CDF at any point x is given as 1 minus e raised to minus x by 15 if x is non-negative. And we know that we can measure time in non-negative units only. So we replace fx by 1 minus e raised to minus x by 15 equal to 0.90. So now it is easy, we have to solve this equation so that we can obtain small x. So this I can rewrite as e raised to minus x by 15 will be equal to 1 minus 0.90, that is 0.10. Now if we take logarithm on both sides, we have logarithm of e raised to minus x by 15. We are taking natural logarithm. So this turns out to be minus x by 15 equal to logarithm of 0.10. So therefore using scientific calculator I obtain this value for logarithm of 0.10. And here we can see minus x by 15 is there. Here also we have negative sign. So x will be equal to 15 into 2.3026. Negative sign will cancel out. And finally we obtain that x equal to 34.5388 minutes. And if we round off up to 2 decimal places, we can write that x is approximately equal to 34.54 minutes. So this is the length of time interval such that probability of at least one call in this time interval is equal to 0.90. So we have find out length of the time interval such that probability of at least one call in that time interval is 0.90. Okay, so we have obtained the value of x such that probability of at least one call in that x minute time interval is 0.90. Okay, so in this way we can do all the subparts. So in this example we have thoroughly applied exponential distribution, and the random variable under consideration was time between calls in minutes. Okay, and this is exponential random variable with parameter was 1 by 15. Okay, so in this way you can find out sum of the probabilities using exponential distribution if your random variable is exponential random variable. Here it is already given that time between calls is exponentially distributed. So it is already given that this is an example of exponential distribution. So you have to remember that mean of exponential distribution is given by 1 over parameter of exponential distribution. So here mean is given, so we can find out parameter by taking reciprocal of mean, and we are using the cumulative distribution function of exponential distribution to calculate probabilities. If x is non-negative, fx is 1 minus e raised to minus lambda x and 0 otherwise. If you wish, you can use probability density function also, so that is your choice. But if we are using CDF, then calculations are less as compared to PDF, because here we have to do integration. Okay. We know that PDF of exponential distribution is lambda times e raised to minus lambda x if x is non-negative and 0 if x is negative. Suppose I want to calculate this probability which was in part C using probability density function, then I have to integrate probability density function between x equal to 5 and 10, and here lambda was 1 by 15. So if you wish, you can use probability density function also. Okay, that is your choice, but I find that using CDF is easy as compared to PDF, because if we are using CDF distribution function, then we have less number of calculations as compared to this probability density function. So this is all about this lecture. I hope you like it. Thank you very much.